Alright, so here we go. Here is the schedule generator that I developed. I'll go through this pretty quickly. But basically, alright, so for the first week, it's pretty straightforward. I run this line of code, and what I get is this vector, which has 12 numbers and 6 matchups. So each of the 12 positions on this vector represents one of the 12 teams, and the numbers 1 through 6 represent 1 through 6 matchups for that week. So in this week, it's telling me that Team 1 is playing against Team 11, whoever those are. Team 2 is playing against Team 12, and so on and so forth. So the same numbers in this vector means that those two teams are playing each other based on the position. So each position represents a team here. And we can turn that into a matrix so we can see what that looks like too. This is just this vector turned into a matrix. So team 1 is playing team 11, team 2 is playing team 12. Wherever the 1 is where the matchup is. So team 3 is playing team 7. I want to make one of these matrices for, I'll make this a little bigger just in case. I want to make one of these matrices for every single week. Okay, that's the goal that I'm doing here. And so in the later weeks, okay, we have constraints because we can't match up the same team, we can't play the same team twice in 1 week, for example. And so in order to develop this matrix for weeks 2 through 14, for the 14 regular season weeks, I have this function called week match. And now it just needs to understand who the teams played last week and who have the teams played in the history of this season. Now what's going to happen basically is it's going to take each team and pass it through this loop. And this loop is going to tell the code who this team can play against. So for example, if I'm the first one to go through this loop, of course, because I'm number 1, I'm the king, unless you forget. First team, Team Rudy's going to pass through, and the first thing that it's going to check is, of course, I can't play myself. Goes without saying, but you need to tell the code that. The second thing that it's going to check is that I can't play a team that is already matched up against another team. Again, it kind of goes without saying, but I need to make sure that the code doesn't reassign a matchup that's already been assigned in that week. These last 3 constraints are the critical ones that we talked about in the chat, and that's this team can't play the same team as last week. That's where I needed to pass that last week's schedule into this function. This team can't play the same team more than twice, and that's where the total schedule comes in. And then we talked about this too, is that this team has to play each team at least once before rematching with any of the other teams. So the last 3 weeks of the regular season are rematches. Now it's going to consider all of those, pump out a group of potential matchups, and then randomly select from that group who, in this case it's me passing through the loop right now, who I can play against in this week. And it's going to randomly assign me to that one of them, and then assign us the matchup. Now, in the later weeks, it might not be able to satisfy, like as we get to the end, for example, if the last 2 teams to be matched up in that week can't be because they defy one of these constraints, it's not going to be able to find a solution, and it's going to tell me that all constraints are not satisfied. And I just need to rerun the code again for that week. Until it finds one. It doesn't affect any of the previous weeks, just for that week. And it does that until we get this matrix for the week that I am calculating it for. And so we do that for all 14 weeks. So I've already done week 1. We can go and do that now using that function I showed you for week 2. And then what this week taught does is it calculates the total matchups because that's one of the inputs into the function. It needs to know the total matchups in the history of the season in order to satisfy one of the constraints. So I've done week 2, I can do it for week 3. Okay, good. Week 4, as you can see, all constraints are not satisfied, so I need to rerun week 4. Doesn't affect week 1, 2, or 3. Okay, we got a good week 4. Now I'm just going to go through until we have schedule for all the remaining weeks. Okay, so now we have good schedules, meaning that they satisfy the constraints for all 14 weeks. I can look at this last week tot, and this shows the total matchups over the entire regular season, and I can see, for example, Team 1 in this first row, of course, never plays itself. That's why the zeros are on the diagonal. Plays every team once and 3 teams twice. 1, 2, 3. Good. Let's say Team 6, same thing. Every team once and 1, 2, 3 teams twice. So we satisfied that constraint. Now we can also visually check out if any team plays a team back to back. With this, what I've done is now in this matrix, each number represents a team. Earlier, the number represented the matchup. Now it represents the team. And it tells me Team 1 is playing Team 11 in week 1. In week 2, so each column is a week. Team 1 is playing Team 7. What I'm looking for is if there are any back-to-backs. There shouldn't be because it would have pumped out an error if it did, but this just so I can visually see what the result looks like. So this would be the result of this generator of the schedules. Another way we could do this randomly is I only pump this out with numbers, but we could do it with numbers and then pick names out of a hat, for example, for which team Team 8 is or which team Team 11 is. You know what I'm saying? So yeah, this is how it works. Let me know if you guys agree on the algorithm and the method. And if you don't, you can fuck yourself.